Hello, I'm Ryan Boyd, and this is going to be a very brief tutorial video on how to analyze data from groups and dyads and other types of transcripts and multiple speaker interactions using Butter. So this is probably one of the most complicated things that you can do in Butter right now, so this might be a bit of a kind of intricate video. I'm going to try to go through this step by step so you get a sense of what's going on. The first thing I'm going to do is show you the sample data that we'll be working with. So often when people, especially in the social sciences, run a study where there's 2 or more people talking, they'll hand transcribe their data to look something like this, where you have speaker identification numbers that open up every single line, something kind of like a tag to let you know who's talking, and then the actual text of the person who's talking. And this is a similar format to what you would find if you have, for example, instant messaging data. I don't know if those are even still around, but older examples would be things like ICQ or AOL Instant Messenger, MSN Messenger, things like that. They all look roughly in the same format, give or take. And so really what we want to do in most cases for these types of analyses is we want to get the text for one of the speakers and put it all together. And then we want to compare the language of person 1 with this other person. Now there are 2 currently popular ways to do this right now. One of them is called language style matching. The other is called something like latent semantic similarity, similar to things like latent semantic indexing. At the end of the day, both of these tasks end up with you taking the text for each person, separating them, analyzing each text separately, and then doing some kind of a comparison between the scores for person 1 and person 2. And if you have more people in the group, you might do person 1 compared to person 2, person 1 compared to person 3, and then person 2 compared to person 3, and so on. Now, there are a few different ways that you can load your data into Butter. The first is using transcripts like these that I just showed you. The other would be if you already have the text separated, you might have them in a spreadsheet file laid out like this, where, let me adjust these column sizes, the row heights. So you might have a column that has a name of the text, and then a column that has all of person 1's text in it, paired with a column that has all of person 2's text in it. So here you can see the text already separated out, and each column has a separate person's text in it, and they're paired. So each one of these rows is a separate dyad. I'm going to show you how to do this with the transcript files first, because this is a bit more complicated, and I think that this is a bit more common. It helps you run these analyses without having to have someone go in and manually separate out all the data. And just as a little plug, one way you can separate out each speaker's data without too much hassle is using some older software that I'd written called ConverSplitter Plus. And that's available online. This same functionality of this software is also present within Butter, so you don't have to do that separately. You can do it within Butter if you want. But if you want just a separate program to do it for you, ConverSplitter Plus does a pretty good job. So there are a few things that we need to do, and I'm going to go ahead and start showing you some of the separate plugins that are involved in this process. So right now I have all these transcripts in Microsoft Word files, doc and docx files. So I'm going to go ahead and use the load docx files from folder plugin. I'm going to go to the settings here and choose the folder that all of these are in. Because I have multiple subfolders, I'm going to make sure to click the Include Subfolders checkbox here. Now, the main category of plugins we're going to be using here is category, dyads, and groups. And some of these are not super obvious what they do. So really, the way that you can think about this is that data can come in a couple of ways, and you can either, so in this case for transcripts, we want to split the conversations up so that we separate each person's text. So I'm going to go ahead and show you something here real quick. So if we go into this, we load up the document files, we go to split the conversations. When we go into the settings here, we see that we're going to need a list of speaker tags. So if we go back to this example transcript, these are the speaker tags, 181.201 and 181.200. Now these are different across all of the different files that we have. So in theory, if you already have a list built, you could go ahead and enter all of those in. In theory, you might have them in a spreadsheet file or a text file or something already, a comprehensive list of all your speaker tags. If you don't, then this plugin doesn't know what the different speaker tags are across all of your files, and it doesn't have any way to smartly split the texts up and aggregate them separately by person. So what we need to do is remove this plugin for now, and we need to detect the speakers in the transcript. And there's a really long description over here in the description box, which gives you some information. And again, if you're curious about some of the more specific details of this, I'd recommend checking out ConverSplitter Plus. Most of the code for these plugins is the same as that software. But what we're going to do is detect speakers in transcript. If I go to the settings here, we see that there are some options that help us detect what all of those speaker tags are. So as a quick example, all of these transcripts, the speaker tags are in the standard format. They're all a series of numbers followed by a colon followed by a space. So here, the speaker tag delimiter, we're going to have colon and space, because that's what really separates out all of the speaker tags from the text itself. So what this plugin will do is go in and look for a colon space. Whatever it finds on the left, it's going to treat as a speaker tag, and whatever it finds on the right, it's going to consider to be the text spoken by that person. Now I'm also going to check output only unique speaker tags. What this is going to do when we generate the output from this plugin is it's just going to give us a list of unique speaker tags. It's not going to tell us every single speaker tag it finds. It's not going to include the same speaker tag if the same speaker tag is used across multiple different files, because we don't need that for the Conversation Splitter plugin, which is where this information is ultimately going to end up. So out of the box, I'm going to leave it like this. There's some other more advanced things you can do if you have timestamps and you need to remove those, for example. We're not going to cover that here. We're just going to leave this as is. And because the detect speakers and transcript plugin outputs an output array, we'll save this to a CSV file. And I'll go to the settings and choose where to put this. I'm going to change the file name to transcript speaker tags. And this should run pretty quickly. This is also a very small example data set. And it's finished already. So I'm going to go ahead and go to that file that it just created. And we can see across all of those files that it looked in, it pulled out a comprehensive list of the speaker tags and also tells us which speakers are appearing in which files together. So we're going to keep this list here and go back into Butter. I'm going to go ahead and remove the Detect Speakers plugin because now we have that complete list. And so now we can use the Conversation Splitter plugin. And when we go back to the settings here, we can just take this list, copy it, and paste it in. And so what this plugin is going to do now is it's going to scan all of these different texts as it reads them in, and then detect the different speakers that we've specified and separate out the text for each speaker. Now once we've done that, you can see the output type is group data. Really, under the hood, you can think of the data like this. If we have, let's see if I can do this fairly easily and quickly. So if we have two speakers, and person 1 says, hello. Person 2 says, hello, how are you? Person 1 says, I'm fine, thanks. Person 2 says, that's great. So this is the raw data that is coming in. What we've done is we have separated out the text, so we have person 1's text all going together. And then we have person 2's text all going together. And that leaves us with hello. I'm fine, thanks. And hello, how are you? That's great. So what this group data is, just to remind you what we're talking about, because that took a while, we have this group data output type. A group data output type is really just a collection of people. So it's just this and this here. And so what we're going to do, all of the plugins from this point out, language style matching, latent, semantic, similarity, is going to analyze this text for person 1, this text for person 2, and then it's going to compare the results to each other. That probably wasn't the most helpful example in the world, but this is not a permanent video, so I'm just going to keep on rolling. So right now, the two types of analyses that you can do on group data are language style matching and latent semantic similarity. So language style matching, I'm going to go ahead and connect this. And this is really measuring the similarity of style between two people. And you can see there are a few citations that I've put in the software here. Under the description, there are several papers out there. easily 20 or 30 papers that use this method. So there's a lot of resources out there to learn more about it if you're unfamiliar with it. And this plugin doesn't have any settings, so LSM is a very kind of prescribed way of analyzing the data. I won't go into too much detail about that because there's a lot of resources for it. You can also do latent semantic similarity. Now, latent semantic similarity, if we go to the settings, we'll see select model file. So latent semantic similarity relies on a pre-trained word vector or some kind of a pre-trained model. And that is something that you can learn more about from the previous video. I've got this pre-trained model here that someone else has made using latent semantic analysis. And if we open this up, it's going to be this familiar format that we talked about in the last video. This is the number of words that are contained in the model. Each word is represented as a 300 dimension vector. And so we're going to go ahead and use this model. This model will be used to tell us how similar each of the speakers are semantically, or how similar their texts are semantically. So I'm going to go ahead and use this model file. And both of these have an output array type. So we can go ahead and attach a save output to CSV plugin to both of those. So what this pipeline is going to do is read in those files. It's going to separate out the speakers using all of these tags that we found earlier. It's going to calculate language style matching scores for every person in each transcript. And it's going to calculate latent semantic similarity scores between each speaker within each transcript. I need to set the output locations for these. Oops. Now I'm going to show you real quick one other thing you can do here. So when these conversations have been split up, they're essentially packaged. They're packaged as group data. What we can do if we want to take those conversations after they've been split up and then do something else with them, we can actually unpack the data. So this conversation splitter automatically takes these texts, chops them up into separate speakers, and puts them in a group data object. If we unpackage that, it takes each of those texts and turns them back into separate strings for each person. And so we can even take those and save them. Let's just save them as text files. So I'm going to go ahead and create a new folder to put these text files in. Transcripts. And we'll just name this transcript txt files. And so that's yet another thing that we're having this analysis pipeline do for us. So let's go ahead and run this, and it'll be a little bit slower because it needs to initialize the latent semantic similarity plugin. So it's reading in that model file that we told it to, so that it can analyze all of our text much more quickly. And it's cooking along at a good speed and finished. So let's go ahead and take a look at all those different outputs that we have. So if we go in, we'll go in reverse order. So these transcript txt files, you can see that we have multiple files for each of the input files. Let's see if I can make this a little bit easier to see. So we can see that the original file names are in the file here, And then the speaker tags are also included so that we have separate texts for each speaker. So both of these people originally were talking in the same file, and we have the text for this person and the text for this person all separated out now. So if you have other things you want to do, you can use these files. Now if we look at the latent semantic similarity and the language style matching outputs, here's the LSM output. So it tells us what the original input file was. We get a unique identifier for this particular match of people. We get the word count for person 1, we get the word count for person 2, and we get the language style matching score for these two people. And let's see if we have a good example of multiple different speakers within the same file. So here we have person 181-246 and 181-426. It's probably a typo in the original transcript, but using the system, we found two separate people here. And so we can see these are all within the same file. So we have this person compared to this person and their language style matching score, the same person compared to another one, and so on. So we get this comprehensive LSM score for every possible pairing of people within the transcript. And the latent semantic similarity scores, the layout of this output is going to be very similar. So we see, again, we have the text identifier, we have the person 1 speaker tag, person 2 speaker tag, the word counts for each person, or the number of captured words for each person for latent semantic similarity, and then the latent semantic similarity score for each pairing of people. And similarly, here we have a collection of different speakers. We're getting comprehensive pairwise LSS scores between all possible combinations of people. So this is kind of the long form, more complex way of getting language style matching and latent semantic similarity scores from transcript files. And this is also just kind of a general introduction to how you can chop up and work with these different dyad and group data plugins in Butter. Now, I'm going to show you real quick, so that this video doesn't run too long, another way that you can do this if you have a different format for your data. So this is what I showed you earlier. I'm going to go ahead and make this a little easier to look at. So let's say you already have your text split up, and you have person 1 in one column, person 2 in another column, and you could have person 3, 4, 5, and so on. This is when your text is already completely split apart. What we'll do is we'll read in text from CSV. I'll choose that transcript file. I'm going to use this column, the text ID column. You might have a file name column, you might have a group number column or something like that as the identifier. And then we're going to choose the columns containing text. We have person 1 contains text and person 2 contains text. Now normally if we were to do this, the way that Butter works is it's going to take all of the different columns that have text and lump them together as a single unit for analysis. Now what we want to do in this case is we want to treat each column as a separate text. So it's going to read each row of the data set and make sure that person 1 text is kept separate from person 2's text. Now, what we have coming out of here, if you remember back to that really crappy example that I drew, is we have 2 people's texts that are separate. And this plugin by default is reading in a CSV file and outputting as a string. We can take that and we can package it up as group data. So in the previous example, the conversation splitter plugin took all the text, chopped them up, and then packaged them as group data. Here, we're going to just read in the text, and because these are being kept separate, we can just take them, package them as group data, and then move on from there. We could calculate language style matching, latent semantic similarity, and we can save these output files. And the results will be essentially the same as what we had before. So I think that that's everything for the group and dyad plugins that you can use for Butter. I think that's it.